When the human body is exposed to low-temperature environments, it initiates a series of physiological responses to maintain core temperature and ensure survival. These responses involve the integumentary, cardiovascular, respiratory, and muscular systems, as well as metabolic adjustments. Understanding how the body reacts to cold can help in managing and mitigating the effects of cold exposure. The primary goal of the body in cold environments is to maintain its core temperature, typically around 37 degrees Celsius. The hypothalamus, located in the brain, acts as the body's thermostat. When it detects a drop in temperature, it triggers several mechanisms to conserve heat and increase heat production. One of the first responses to cold exposure is vasoconstriction. The blood vessels near the surface of the skin constrict to reduce blood flow to the extremities. This response minimizes heat loss by directing warm blood towards the vital organs in the core of the body. While this helps preserve core temperature, it can lead to a decrease in the temperature of the skin and extremities, making them more susceptible to frostbite and other cold-related injuries. Shivering is another critical response to cold. This involuntary muscle activity generates heat through rapid, repeated muscle contractions. Shivering can significantly increase the body's heat production, sometimes by as much as 5 times the normal resting level. Although effective, shivering also increases energy expenditure, which can lead to fatigue if the individual is exposed to cold for prolonged periods. Non-shivering thermogenesis is another method the body uses to generate heat. This process occurs primarily in brown adipose tissue, which is rich in mitochondria. These mitochondria burn fatty acids to produce heat instead of ATP, the usual energy currency of the cell. This mechanism is especially important in infants, who have a higher proportion of brown fat compared to adults. The respiratory system also plays a role in the body's response to cold. Breathing in cold air can lead to bronchoconstriction, a narrowing of the airways which helps to warm and humidify the air before it reaches the lungs. However, this can also make breathing more difficult, particularly for individuals with respiratory conditions like asthma. Cold exposure can affect the cardiovascular system in several ways. In addition to vasoconstriction, which raises blood pressure, the heart rate may initially increase to boost blood circulation. Over time, however, prolonged exposure to cold can lead to a decrease in heart rate and a condition known as bradycardia, which is characterized by an abnormally slow heart rate. The body's metabolic rate also increases in response to cold. This heightened metabolism helps generate additional heat through the increased breakdown of nutrients. The thyroid gland releases more thyroid hormones, which play a key role in regulating metabolism. This response is essential for sustaining the energy demands of shivering and other thermogenic processes. Cold environments can also impact the nervous system. Sensory nerves in the skin detect cold and send signals to the brain, which then orchestrates the body's responses. Prolonged exposure to cold can lead to numbness and a loss of fine motor skills as nerve conduction slows. Severe cold exposure can impair cognitive function, leading to confusion and impaired judgment, which can be dangerous in survival situations. Hypothermia is a critical condition that arises when the body's heat loss exceeds its heat production, leading to a drop in core temperature below 35 degrees Celsius. Hypothermia progresses through several stages. In the initial stage, also known as mild hypothermia, the body shivers intensely and begins to lose fine motor control. The skin appears pale and the person may feel confused or disoriented. As hypothermia progresses to a more severe stage, shivering becomes more violent and coordination deteriorates significantly. The person may have difficulty speaking, walking, or thinking clearly. The risk of cardiac arrhythmias increases, as does the potential for unconsciousness. In the final, most severe stage of hypothermia, shivering stops altogether as the body's heat production systems fail. The person may become unconscious and vital functions slow down dramatically. Without immediate medical intervention, this stage can lead to death. Frostbite is another serious consequence of cold exposure, occurring when skin and underlying tissues freeze. Frostbite typically affects extremities such as fingers, toes, ears, and the nose. Symptoms include numbness, tingling, and a pale or blue discoloration of the skin. In severe cases, tissues may die, leading to gangrene and the potential need for amputation. In response to cold, the body also experiences behavioral adaptations. People instinctively seek shelter, put on additional clothing, and consume warm food and beverages to increase internal heat. Proper clothing is crucial. Materials like wool and synthetic fibers provide better insulation than cotton. Layering clothing traps air between layers, enhancing insulation. In addition to these immediate responses, acclimatization to cold can occur over time. People who live in cold environments for extended periods develop physiological adaptations that improve their ability to tolerate cold. These adaptations can include enhanced blood flow to extremities, improved cold-induced vasodilation, and increased metabolic heat production. Cold acclimatization can also involve psychological adjustments. Individuals become more skilled at recognizing the early signs of cold stress and take preventive actions more effectively. They may also develop better strategies for maintaining body heat, such as optimizing clothing and shelter. It's important to recognize that certain populations are more vulnerable to the effects of cold. Infants and elderly individuals have a reduced ability to regulate body temperature and generate heat. People with medical conditions such as cardiovascular disease, diabetes, and hypothyroidism are also at higher risk. Additionally, individuals who are malnourished or under the influence of alcohol or drugs are more susceptible to hypothermia. Preventing cold-related injuries and illnesses involves several strategies. Adequate clothing and shelter are the first lines of defense. It's important to dress in layers, wear hats and gloves, and ensure that clothing remains dry. Wet clothing loses its insulating properties, increasing the risk of hypothermia. Staying active can help maintain body heat, but it's important to avoid overexertion, which can lead to sweating and subsequent heat loss. Consuming high-calorie foods and warm beverages can provide the energy needed for thermogenesis. Alcohol should be avoided, as it impairs the body's ability to regulate temperature and can lead to risky behaviors. In situations where hypothermia is suspected, it's crucial to act quickly. The affected person should be moved to a warm environment and wet clothing should be removed. Rewarming can be done gradually using blankets, warm water bottles, or body heat from another person. It's important to avoid rapid rewarming, which can cause shock. In severe cases, medical attention is necessary. Understanding the body's responses to cold and taking preventive measures can significantly reduce the risk of cold-related injuries and illnesses. By recognizing the signs of cold stress and knowing how to respond, individuals can better protect themselves and others in cold environments. In conclusion, the human body's reaction to low-temperature environments involves a complex interplay of physiological and behavioral responses designed to maintain core temperature and ensure survival. These responses include vasoconstriction, shivering, non-shivering thermogenesis, and increased metabolic rate, among others. The body's ability to adapt to cold through acclimatization and behavioral strategies is essential for surviving and thriving in cold climates. However, it is important to recognize the signs of cold stress and take appropriate measures to prevent and treat cold-related injuries and illnesses.